Welcome. My name is Alberto Contreras, and together with my partner Sam Hammond, we have created this presentation to help you better understand and grasp this new concept. This is a new presentation about the state transition diagrams. We hope that it will be enjoyable and educational to you as we discuss it. We will be going over a brief summary of what the state transition diagram is and why it is applicable to the things we are doing in the course. We will then guide you through the correct way to implement the diagram and give you a relevant example of the diagram in action. Please enjoy. What is a state transition diagram? To start us off today, we will discuss the definition of the state transition diagram. The state transition diagram is a graphical representation of a machine with a finite number of states. This particular diagram is defined for each relevant class in the system. The state transition diagram shows the possible history of a given class or object. This includes all the possible states of the class, each event received from the outside world that would lead to a transition from one state to another, and any actions that can result from the state change. So you can see that the state transition diagram is the life history of a class from its creation to its destruction. How to implement the state transition diagram. Nodes. Here we have an example of a node. It can be in an oval shape or rectangular, and this is one of the basic notation for the state transition diagram. Okay, then we have here the event, the arc. The next part of this diagram is represented by an arrow that transitions from one state to another. This arc is labeled by an event. The transition is triggered if an occurrence in the outside world matches the event labeled on the transition arc. How to implement the state transition diagram action? Some events may contain actions that go along with the event triggering the transition. They may also contain attributes or conditions, such as a Boolean condition guarding the event being triggered. Actions or activities can also occur when you have transitioned to a new state. Activities are operations performed by an object when it is a certain state. Entry actions are instantaneously performed by the object when the new state is triggered. There is also the option to use exit actions, which are performed at the end of each state. How to implement the state transition diagram. Recurring transitions. Now, there are some different variations of transitions arcs. One more commonly used is the recurring transition arc. When this event is triggered, it repeats the same state that was active previously. This event can repeat until a certain required condition is met. So I will show you a general example. This is something like eBay and when you bid for stuff. Okay, so these are cases or states. It's listed, ignored, sold, active. We have here the start position. We have here an example of an event when somebody bids. Okay, that's an event. We see here also the guard. That's just something like a Boolean, and it'll keep repeating until that a Boolean is true. Okay, so we see here an example of it. So we'll start from the beginning. So you see the transition here, the arc that the time starts. That's an action. It's gonna be in that state of listed until the time expires or somebody bids. Nobody bids, you can see there's gonna be it's gonna be ignored, and then you can list it again, right, with the transition. So you can see how the state machine works. Then we have here if somebody bids, so it's going to be active, and then people can keep bidding, keep bidding, keep bidding, keep bidding until the time expires. And then you have here actions. They will notify the seller, they will notify the buyer, and then it'll change to the last date, which is sold. This is where I want to spend the rest of the time. The specific example for our application for the map. So I was thinking where we can use it the most is on our task. Assigning the task, completing it. I think there's a lot of finite states, like we mentioned previously, that we can have it as new, we can have it in progress, show that it's completed, or if it's canceled. Okay, so we start the diagram, and the transition is going to be create the task. That's going to be the event. It's going to create the task, so now it's in a state of new. From then we can cancel it if it was submitted incorrectly, or we can assign the task. That's another event that will change it to in progress. An action can be add reminders, as you see there in the transition arc between new and in progress. Add reminders for the employee, for the supervisor. That's an example. Then from the state in progress, we're gonna keep recurring, as you see here, working on the task until it is completed, until the boolean of completed becomes true. Then it's gonna be able to go down into that transition arc, and the event will be task completed. And then we can do some actions like remove reminders, notify the client that we were helping this task, notify the manager, and it'll go to the state completed. So here's a clear example of how you can implement this transition diagram for the application that we have working on. The advantages to using this diagram are the state transition can be really useful. It is very advantageous when you're looking to describe the behavior of a single object. It makes the explanation of the functionality of an object easy to follow and visualize. The state transition diagram is relatively easy to understand and produce. Some of the disadvantages of using this diagram: as you can expect, the state transition diagram isn't always the best option when looking to represent the functionality of an object. It can be specifically difficult when trying to represent the functions of several objects working together. The flow of the state transition diagram isn't built for jumping between objects to complete a task. In conclusion, state transition diagrams is a great way to represent and to better understand how to approach the programming of a class that has finite number of states. In our case, for our application, for the task class specifically. And these are our sources that we have. We appreciate you taking the time. Thank you.